Hello everyone. Today we'll show you how to measure the various resistances with the help of this digital multimeter. I've already told you that there are various uses of a digital multimeter. It can measure the voltage, it can measure the current, it can measure the resistance. Not only that, it can check the continuity, it can check the square wave, it can find out the HFE of transistors of both NPN and PNP transistors. Today I will show you how to measure resistances with the help of this digital multimeter. You see here, there are various types of resistances here. You should know that there are various types of resistances. You see, these are one of the type of resistances. We measure the resistance of these resistors, right? Let us find out what is the resistance, how you have to measure, right? Here you have to see what you have to do. You see, in this digital multimeter you have to set this arrow. This is the arrow. You have to set this arrow in the resistance range. You see, this is the resistance range. This is 200 ohm, this is 2000 ohm, this is 20k. K means 1000, right? This is 200k, this is 2000k ohm resistance, right? We'll find the resistances of these. We'll find the how much resistance of these resistances, right? Then you have to put this arrow in the resistance of 200 ohm. Here you see 200 ohm. See here, we put this here in the, you can see it very clearly, right? We put the arrow in the 200 ohm resistance because these resistances are below 200 ohm, right? This range is up to 200, right? That's why I put this it under 200 range. Now this is the positive one and this is the negative one. Let us check the resistance of these resistance. Let us check this resistance first, right? If we check this resistance and find what is the resistance of this resistance resistor, let us check this one. We connect this with the one terminal, one end, and connect it with other end and check the reading. You see here, we are getting the reading as 20.0, that is 20 ohm. That means the resistance of this resistor is 20 ohm. You see here, this is 20 ohm, right? It is 20 ohm, exactly 20 ohm. And then check whether it is 20 ohm or not. If you see it here, that it is written as 20 ohm. You see here, you see it very clearly that it is written as 20 ohm, right? You see here, it is 20 ohm, 20 OHMS 20 ohm. Therefore, our reading is exactly correct. That is, it is 20 ohm, right? Now we will measure another resistance. This one is green in color. Let us find what is the resistance of this one, right? Let us check whether what is the resistance of this one. Let us check this one. Then we will add this positive terminal with one end and this negative with the other end, and we will check what is the resistance. It is, you see the reading, it is, you check the reading, it is nearly 27.8 ohm, 27.8. Nearly 20. You see, it is 27.9 ohm, and if we check it, it is given as 30 ohms, right? You check it here, it is 30 ohm. That is, we got the nearest reading, 28 ohm or it is about 30 ohm, right? It may vary 1 or 2 ohms. It may vary, right? This is 30 ohm. Now if we check this red resistance, let us check what is the resistance of this red resistor, right? Let us check this one. We connect this red probe in one end and connect this black ray in the other end and check what is the resistance. You see here, you can see here that the resistance of this red one is 10.7 ohm. 10.7, we check whether it is 10.7 ohm or not. You see here it is exactly so it is written as 10 ohm. That we got it, right? Exactly 10 ohm. This is 10 ohm, right? And let us check these resistances. This resistance. What is the resistance of this resistor? We'll check, put this connection at one end and this one at other end and get what is the resistance of this one. It is 19.4, 19 point, let us check, 19.3 ohm, 19.3 ohm, that means nearly 20 ohm, and you see here it is 20, exactly 20 ohms, right? Then it is varying as 1 or 2 ohm, but we are getting the exact reading with the help of this digital multimeter. Now I will show you what is the variation in the resistance if we connect it within series or connected in parallel. What is the output? So, right, you see here we have already told you that this one is 10 ohm. You see this red one is 10 ohm and this blue one is 10 ohm. Now if we see this resistor, that is red one is 10 ohm, you can see here it is 10 ohm. You see this is 10 ohm and it is also 10 ohm. It is 20 ohm. Let us take 10 ohm. This is 10 ohm. We are taking this one, blue one. You see here it is 20 ohm. Right, you can see here it is 20 ohm and this blue one is also 20 ohm, right? These are the two resistors 20 ohm and 20 ohm. Now we will see what is the output if we connect these resistance in series or in parallel. Let us first connect these resistors in series and we will find what is the resultant, right? Here see we are connected these in series with the help of one connecting wire. You see here we are connected this with this one. We connected both the resistors in series connection and let us find what we are getting. You see here we are connected this one with this one. We have connected these two resistors in series and we will measure what is the resultant resistance of these two resistors. We have connected it in series. Yes, we have connected in series and let us check what is the resultant resistance of these two resistances resistors connected in series. We put this at one end and take this at other end and we'll find what is the resistance. You see 39.2, that is 20 plus 20 is 40 ohm. That means resistance are added in series connection, right? That means we can say that resistance are added in series connection. And later on we'll see what is the result if we add these resistances in parallel, right? If we add another resistor, that is it is 30 ohm. You see here, this is 30 ohm, this is 20, this is 20, and this is 30. If we connect these three resistors in series, we'll get 30, 40, 50, 60, 70 ohm. Let us check. We have to connect these two resistors again with the help of a connector. With the help of this, we have connected all these resistors in series, and let's check how much we are getting. You see that all the resistances will be added up, right? You see here, we have connected all the distances in series. This is connected with this, and this is connected with this, and we'll check in this connect and this in this way, right? Let us check. We connect this at one end, and we connect these at other end, and we check the resistance. You see it is increasing 68.6 volt, right? That is nearly 70 volt, 70 ohm, not volt, it is 70 ohm. It is resistances, that is 20 ohm plus 20 ohm, 40 ohm plus 30 ohm, that is 70 ohm. That means if we connect these resistances in series, then the resistances are added up, right? And if we connect another resistance in series, let's check what happens. That is 20 plus 20 40 plus 30 70, 70 plus this is 10 ohm, that is 80. Let us connect these with another connector and let us find out what we are getting. You see here, we are connecting this one with this resistance, and we will find what is the resistance of these resistors connected in series. There are four resistances, and here you see we are connecting this one here and this one here, and we are getting how much? You see 103.5, 103.6, 103.6 ohm, right? That means if we connect all the resistances in series, then the resistances are added up. You see here we are getting 20 plus 20 40 ohm plus 30 70 ohm plus 10 80 ohm, and these are connected in these are the different wires. That's why we are getting nearly 100 ohm, right? See, these wires have some resistances, and these are added up, and we are getting nearly 100 ohm, right? That means if we connect the resistance in series, then we are getting the resistance are added up in the series connection. And we will check now how, if we add the resistance in parallel, what is the result, right? Let us check, right? In the conclusion, you can say that if we add all the resistances in series, then the resistances are added up. You see here we are checking once again. You see the resistance is nearly 109.9 ohm, right? That means all the resistances are added up in series connection, right? Now let us check what will happen if we put the resistances in parallel connection. Let us check. Okay, let us check if we put it in parallel connection, what is the result. That means if we connect the resistances in series, the resistances will be added up, right? And what happens if we connect in parallel? Now we'll check parallel connection. You see this is 20 ohm. You can see here that it is 20 ohm, and it is also 20 ohm. See here, it is also 20 ohm, and it is also the blue ones, both are 20 ohms. 20 ohms, right? Now if we connect these two resistances in parallel, let us check what happens. You see here we are connecting this in parallel. This one is connected with this one. This one is connected with this one, and another connection we are making. The resistance are connected in parallel. What happens? Now you see these resistances are connected in parallel, and if we now measure the resistance of these two resistors, let us find what is the reading. It is nearly 11.2 ohm. It is nearly 11.2 ohm. How we are getting? What is the solution? That means it is 20 ohm, and it is 20 ohm. We know that if we put the resistance in parallel, then the formula to find the equivalent resistance is 1 by R equal to 1 by R1 plus R2, 1 by R2. And in this way you can find the resistance of equivalent resistance. Let us find out. You see here, R1 is 20 ohm and R2 is also 20 ohm. Let us find the calculation. Right? Here you see. Here R1 is 20 ohm. 20 ohm. You can see here R2 is also 20 ohm, and the formula for equivalent resistance is 1 by R is equal to 1 by R1 plus 1 by R2. That means 1 by R is equal to 1 by 20 plus 1 by 20. That means if we add this one, that is 20, 1 plus 1, that is 2 by 20, or that is 1 by 10. 1 by R is equal to 1 by 10, therefore R is equal to 10 ohm. Right? In the same way we are getting here, see, if we connect these resistance in parallel, then we are getting nearly 10 ohm. You see here. You see, we are getting 10.7 ohm, right? That means if we connect the resistances in parallel connection, then the formula for resultant resistance is 1 by R equal to 1 by R1 plus R2. You can see here that we have calculated it in this way, that 1 by R, see here, right? R1 is 20 ohm, R2 is 20 ohm, and the resultant resistance will be 1 by R equal to 1 by R1 plus 1 by R2. That is 1 by R equal to 1 by 20 plus 1 by 20, and 1 plus 1, 20, 2 by 20, that is 1 by 10, R is equal to 10 ohm. And we already solved this, so we have shown that if we connected these two resistances in parallel, then we are getting 10 ohm. This is 20 ohm, this is 20 ohm, but the resultant is 10 ohm, right? In this way we can mix up the resistances in series and parallel connection to get the desired value of resistances. We can get any other value in desired resistances, right? That means if we connect all the resistors in series, then the resistances should be added up. That is, the equivalent resistance R is equal to R1 plus R2 plus R3 plus R4. But if we connect the resistances in parallel connection, then the value of equivalent resistance is equal to 1 by R equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Right? This is the way how we have measured resistances, and we have shown you the resultant of parallel and series connection. Dear friends, if you like this video, please subscribe, like and share. Thank you everybody for watching this video.